Hi everyone. I'm going to get started recording our first presentation. I don't know why it's doing that. All right. This week we're talking about introduction to math methods. So I'm going to first share my screen with you all. So hopefully you can see this. And I'm going to go over to our presentation and I'm going to start talking. So here we go. Okay, so welcome to Math Methods, and this presentation is going to be about the introduction to our course and also big ideas. So our learning objectives are students demonstrate the ability to be an effective member of a professional learning community and a nation of lifelong learners. And students also demonstrate an understanding to various approaches to teaching math, as well as an understanding of their own approach and philosophy regarding math. So I'm going to ask you to take part in a Flipgrid activity. And you don't have to do it now, but you can do it after you're done listening to this short presentation. I want to know your experience with math, how you feel about teaching math to young children, the words that come to mind when you think about math, and you're going to share your story on our Flipgrid. So this link will be sent to you and available in our Module 1 material. So a lot of times people have math anxiety, and this math anxiety can cause stress when it comes to having to teach young children math. So that's something that we want to get over, basically, or find ways to feel more confident in teaching math. So it's something that research has suggested that when pre-service teachers like yourselves have opportunities to teach math and to practice it, that they become more confident. So that's why we are doing those service learning activities where you will be practicing teaching math, hopefully to young children, and if not, you can teach it to anybody, and we'll talk about that. So something else that I want you to consider is understanding and doing math. So research and reports emphasize the need to address skills and understanding in an integrated manner. Although children might know math, do they really understand it? You know, I'm sure you've all heard or been told or been asked to show your work. So the reason for this is, how will we know that they really understand it and get the process if they just give us the answer, right? So what are some other ways? How can you tell if someone really gets it? I want you to think about that because we're going to be talking about it more. Okay, the Common Core state standards are standards that we are going to use within this class. And you may have used them in other classes, but it's something we're definitely going to use in this class. The standards were a state-led effort that's been by almost every state and the District of Columbia. And the effort resulted in how math is taught and not just what is taught. So we'll talk about these standards and some of the differences that may be evident when you're looking at how young children are being taught math today. Another really interesting thing that I think you should know is that there's still these standards, although we have adopted them in Pennsylvania, this can change at any time. So the state can decide not to use them or change what they're doing. So that's something you really should be aware of. But as of right now, Pennsylvania is using the Common Core state standards. All right, so the National Council of Teachers of Mathematics is a great resource that you should check out when you get a chance. And they talk about process standards. So they're saying that these are the ways that we want young children to be able to learn math and really to be able to, again, it's not about the final product, it's about the process. So the process is problem solving, reasoning and proof, representation, communication, and connections. And these are all ways to think about how children should engage in learning math. So again, we'll talk about these things, these processes that we can develop in our students. Okay, this is a short little video about developing mathematical proficiency. And one of the things that Christina talks about in this video is, basically, we don't have to just use a textbook and be led only by that textbook. We really need to think deeper than that and allow children to think deeper than that. And we want our teaching to go beyond just teaching with a textbook. So she uses the mathematical proficiencies that Adding It Up developed. And those proficiencies are that children would develop conceptual understanding, so comprehensive of math concepts, operations, and relations, procedural fluency, a skill in carrying out the procedures flexibly, accurately, efficiently, and appropriately, productive disposition, which is the inclination to see math as sensible, usable, or useful and worthwhile, adaptive reasoning, capacity for logical thought, reflection, explanation, and justification, and strategic competence, the ability to formulate, represent, and solve math problems. So this is what we truly want to develop in our students when we're teaching them math. So these strands of math proficiency that are talked about in the video, and so the video will be linked in your Module 1 resources so that you can watch it there. The interaction among teachers, students, and math should be inside of a context so that they are able to practice these strands of conceptual understanding, procedural fluency, productive disposition, adaptive reasoning, and strategic competence. And also this whole point of using a textbook. So we're going to use a textbook as the to teach math to young children, but it's not the end all in what we're doing. Math, it's a tool. And I even say this when I ask people to get textbooks for my courses. The textbooks are always used as a tool to teaching. In the textbook that we're using for this course, I would like you to check out figure 1.1, and it is on page 2 of my book. So if you have a different version, it might be on a different page. All right. So Adding It Up is also a book that I'm sharing within our module. I was able to download it for free, and I placed it in the folder for you to see. But there's all this research on how children learn math. And again, this is where those 5 strands came from. And this idea of developing these strands when we're teaching mathematics to young children. So this constructivism theory is very relevant in math teaching. Remember, learners are creators of their own knowledge. People connect existing ideas to new information. Remember, you learned about this in child development, assimilation and accommodation. It works in math teaching as well. And understanding exists along a continuum. And then we have the sociocultural theory. This is Vygotsky. Actively engage and working with others who are more knowledgeable. So that's why putting students with peers can be very helpful. And this is this whole idea of the zone of proximal development. So maybe students may not be able to work with some math concepts alone, but they can do it with SCAP and with support. And then in chapter 1, we talk about relational understanding versus instrumental understanding. Instrumental is memory without understanding. Relational is knowing what to do and why. And then this whole learner-centered classroom idea begins where the children are and with the children's ideas. So we want to definitely start with our math teaching where children are. So I want you to stop and think about how many different ways you can think to solve 36 plus 25. So quickly in your head, think about that. And you'll see throughout our text that there's going to be a lot of stop and think for you to consider, or stop and reflect. So this one is actually on page 8. And if you read further, it talks about solutions and how children might be thinking. Here again is this idea of instrumental versus relational. So we want to move to this relational teaching of math. There's multiple ways to solve a problem. Children discuss what to do, and then new ideas and connections are more easily formed. So we want to get away from this. This is the way to solve it, where children are being told how to solve a problem, and then they have actually fewer opportunities to build those connections. So why are children's ideas important? So children have opportunities to look, think about relationships, and then choose a strategy. We want to give them that time. So if we don't seek out children's ideas, children will think math is a body of skills and procedures that are learned by waiting for the teacher to tell them what to do. We don't want that. We want children to be critical thinkers and problem solvers. And we want them to have the self-esteem, I guess I would say, or the confidence or the growth mindset to know that if they think about something, they can figure it out. And if they make a mistake, it's okay. And that's something too that we're going to talk about. So what would a mathematics classroom look like that promotes understanding? First of all, teachers should not be doing the thinking, reasoning, and connecting for children. We want them to do those things. We also want to create a culture where children can learn from each other. You know, how can we do this in a virtual classroom? That's something we all need to consider right now. Also, in a mathematical classroom that promotes understanding, we work off of our children's ideas. They're the key. What are they saying? What are they thinking? And let's go from there. Also, multiple approaches are encouraged. Mistakes, as I just talked about, are opportunities for learning, and math actually makes sense to them. So the Erickson Institute created this big ideas of early mathematics. Evidence shows there is more time spent on literacy in the American classrooms than math, and more teachers are confident teaching literacy over math. Presently, math competence early on is a predictor of school success across the curriculum. So the Erikson Institute wants to change that. They want math to be something that teachers are confident in teaching. So they've created this big ideas and what should be taught for early mathematics. So that I've shared also a document that I think you'll find helpful within Module 1. So again, what is a big idea? It's a mathematically central and coherent idea. It's consistent with children's thinking. It's generative of future learning. So if they get this big idea now, they're going to continue to learn it. This is that spiraling type of learning, right? They learn a little bit here, and then they build on it again and again and again and again until they get it. In addition, it's comprehensive, thoughtful about content, developmentally organized, and also flexible. So we want to be teachers who are also flexible and can change things and can adapt and kind of understand the big picture. So how can we build our approach to early math with big ideas? One thing we can do is mathematize the world around us. So when we see things, ask children questions that relate to math. Make mathematics more than manipulatives. Recognize that some children might not be able to express their understanding, but that doesn't mean they don't have a receptive understanding, that they're actually able to understand. They just may not have been able to express their understanding yet. Get math in children's eyes, ears, hands, and feet any chance you can. And scaffold children to construct their own understanding. So pay attention when observing, either if you're out in the field, I don't know if that's happening right now, at home, at work. I want you to listen, observe, and watch children. How can you relate anything they're saying or doing to math? So this says come in next time with your own story to share, but I want you to think about this and be ready to share in one of our live sessions. So what should you do for next week? Read chapter 1. Draw, write, or create a one-page summary of what you learned. You can take a picture of it, type it up, whatever you want to do, and submit this on Blackboard for credit. Be creative and have fun with this. Those are my references, and that's it. All right, thanks. If you have any questions or you need to contact me, please send me an email. Have a wonderful day. Bye.